My name is Hannah. I work on the Protocol Labs on Bedrock team. I help enable retrieval on Filecoin, as well as interop between IPFS and Filecoin. Generally, I spend my time thinking about how to move data around our networks better, and I've worked on some of the core transfer protocols that, and I'm excited today to help you understand the space. If you need to reach me, my handle is Tech Girl Wonder on most social media places, and you can email me at hannah.howard@protocol.ai. No guarantees. So, let's talk about what we're going to be talking about today. I'd like to give you an idea of what you can expect if you choose to spend your afternoon with us here in the Data Transfer Thunderdome. So for the first hour, you're going to get an introduction. I'm going to introduce the basics of content address data, and then we'll hear a talk from Mauve about IPLD, the data model that IPFS is built on. Then we're going to take a break, and during the second hour, we will actually dive into a tutorial of sorts. It's going to be a little bit funky with the internet. And we'll also hear about Bitswap from Dig on the IRO team. Dig just finished writing the newest implementation of Bitswap, and he's going to share some highs and possibly some lows of IPFS's oldest data transfer protocol. Finally, in the third hour, we'll look at the future of decentralized data transfer. We're going to hear from Jeropo on the Kubo team, who's working on a new client for Bitswap and other protocols. Our resident IPLD expert, Rob, is going to be digging in with us into some of the more complex content address data structures and talking about their implications for data transfer. And finally, we'll close with some of my own thoughts and ramblings about how this could all work even better and more awesomer than it does today, because it's very awesome. Anyway, diving deeper, future of data transfer. Sorry about that. We've got a really wonderful lineup of some of the smartest folks working in this ecosystem. I hope by the end of this track, you will be as interested in the challenges that they all face as I personally am. Maybe in the future, someone in this room will contribute to solving data transfer on content address networks. So yeah, cool. Okay, since you all are the future, I would like to know a little bit more about you. So a prefix on this track, it was originally planned in my head to operate in a small room with about 5 to 10 people. As it turns out, we're in a wee bit bigger room, so we can't quite go around and do introductions. So we're going to have to do a selective volunteering system. So what I would love for you to do is, if you want to volunteer, and I'm probably going to do maybe 5 to 10 people, just to keep it reasonable, is maybe start by saying your name. Then tell us something you like that starts with the same letter as your name starts with, your alliterative affinity, if you will. This will help us remember who you are. You can maybe tell us where you're coming from, and finally, what you hope to get out of this track. And for those of you guys who just love your introductions, warning, you got 30 seconds total. Maybe it's 60. I'm going to just tell our wonderful AV support folks to take the microphone out of your hands. So, cool, yay. Who wants to volunteer and talk to a room of 100 people? I mean, I say it that way because let's all chill out and be cool with each other and, say hello. Raise your hand. Wow, I'll go. I'm Hannah. I like Halloween because it's coming up. I'm from Los Angeles, California, and what I'm hoping to get out of this track today is I would love for someone else to solve the problems that I can't solve. So this is sort of a outsourcing the work presentation. So yeah, who else? Raise your hand. Yay! Cool. Thank you for our first volunteer. Again, what could have been a small room, it isn't.
So I'm Rüdiger. I like Rust. I am originally from Frankfurt and now live near Sibiu in Romania. And I would like to get out of this track that there's something like BitSwap, but much, much faster.
Nice. You would love to find the magic BitSwap successor that totally is awesome. We'll see about that, delivering it, but yes. Who else? You can just like flag the person with the mic. Yay, cool. What about, quite possibly one of our speakers, but shh.
My name is Mauve. I like meeting people. So I'm coming from Ottawa, Ontario, Canada. And personally, I'm interested in talking to people about data and databases and how we can efficiently query it over various data transfer protocols.
Cool. Welcome, Mauve. Yay. Round of applause. So that everyone knows if you speak, you get a round of applause too. Anyone else? 3 more people. Come on, say hello. Yay. You do not have to be an expert in IPFS, data transfer, programming, anything. Just say hello.
My name is Ian, and I have 2 alliterative affinities. IPFS, I feel like I have to pick that one. But I like Sir Ian as well, wonderful actor. I'm coming from San Francisco, and I am really excited to learn all about IPLD.
Yay. Yeah, this is secretly the IPLD also track. We're going to have some awesome IPLD talks. Go ahead.
Hey, I'm Bengo. I work on Web3 storage. We implement Elastic IPFS, which does BitSwap, and probably will do other things in the future. Coming from San Francisco, and yeah, I want to learn about should we use GraphSync? Should we use IPLD? Should we invent another thing? Yeah.
Nice. You want to figure out which of these protocols will solve your immediate problems. Yes, one more. I love it. Now people are like, I want to tell everyone
Hi,
about me.
everyone. I am Albiona. I come from Kosovo, Prizren. I'm a community person, DevRel in general. I am here for the first time in the IPFS community, and I'm a volunteer today. So I'm here for connecting with people. I would like to get to know more people who are doing work in community and engineering at the same time.
Yay. I'm hoping to connect with all of you at some point today, even though some of us will be standing up on the stage. Anyone else? We have 5, so we can stop. But who wants to say hello? That's okay. All right. Thank you all. Yay. Sorry, I just hate talking to faceless rooms. So, cool. Data transfer in IPFS. Super easy. Barely an inconvenience. Data transfer itself is a concept that is older than even the web, okay? You probably can think of some ways we've transferred data in the past and today. HTTP is a protocol that moves data around Web 2. There are so many other ways to move data, though, and it goes way back. There's FTP. Raise your hand if you know FTP. Okay, yay, I'm not as old as I think I am. BitTorrent, USB thumb drives. Anybody remember zip disks? Yes, floppy disks? Yeah, all right, cool. US Post, there's lots of ways to move data around. So if there's tons of ways to move data around, what makes data transfer unique in IPFS? So to answer that, I think we need to ask a more fundamental question, which is, what is IPFS? Okay, have any of the workshops answered this so far? I don't even know. Like, I've had to be working on my track, but like, it's kind of a complicated question. Like, presumably, the interplanetary file system means something because you all came to Lisbon for a conference about it. But what makes IPFS an IPFS, right? So I could think of some things that are part of IPFS, some components you tend to see in IPFS implementations. You've heard of libp2p, the peer-to-peer networking stack, UnixFS, a content addressed file system. You might have heard of IPLD, a data model, maybe BitSwap, a transport, IPNS, a naming system. Maybe you've heard of the IPFS gateways. Maybe you've heard of a DHT, right? You could say that IPFS is just the sum total of all these components. But then if you look around at the different implementations, you'll see that they actually pick and choose. Many of them try to support as many as they can, but not all of them support all these components. And in fact, there's a number of implementations that maybe only support one or two, right? So while all these components are part of IPFS, I'd like to ask, what's like the minimum baseline for IPFS? In other words, what part of IPFS can't you take away? Because without it, it wouldn't be IPFS. So this is when you want to look to an authority on this. And fortunately, our founder, Juan, offered a really good answer at IPFS thing last June. He basically said that IPFS must work with content address data, right? In IPFS, content is always uniquely identified by a unique cryptographic identifier, right? By a cryptographic identifier that can verify the data you're fetching's authenticity with no additional information, right? This is known as content addressing, and it's the baseline of IPFS. If it's not content address, it's not IPFS, right? By the way, this is possible. This is not the direct quote, but you should feel free to spread it around as if it is. I like quoting Juan, misquoting Juan. So yeah, so IPFS is content address data, and so what we're really talking about when we say data transfer in IPFS, I want to offer a clearer view that we're really talking about content address data transfer, right? We mean data transfer for content address data. And that's actually pretty important, right? So content address, how does content addressing affect data transfer? To answer that, I want to talk for a minute about the way we currently get data on the internet, right? So when I want a piece of content, I go to a website address. But how do I know I got what I asked for? Anyone? No? It's actually kind of complicated. The answer is I don't really know, right? Theoretically, I can ask for my login on gmail.com, but if for some reason someone were to intercept that request, they could send me something back that looks like Gmail, but will actually steal my password, right? Now, I have a piece of assurance, and that's that most websites of any size have this certificate of authenticity. We call it an SSL certificate. And this tells me, and also I can only get, the URL is a little bit of assurance, right? That's I have some assurance in DNS, that the DNS records point to the right place. So all that tells me is that I got my Gmail login form from Google. But this introduces a lot of limitations in how I request data. If I want a Wikipedia article, there's only one place I can request it from, right? And that's Wikipedia's own website. And the reason is because I have no other way to verify. If it doesn't come from wikipedia.com, how do I know it's Wikipedia, right? So when we transfer content address data, we ask for data via this cryptographic hash that uniquely identifies the data, right? We say, I just want the data that matches this hash. In the case of IPFS, we call this identifier a SID, or content identifier, and the data we're downloading, we tend to call it a block. What that means is that when you get the data back, no matter whom you got it from, you can verify its authenticity using the cryptographic hash we use to find it, right? Essentially, content address data verifies itself. You don't need anything else. And this opens up a ton of possibilities, particularly around multi-party data transfer. This is the potential superpower of content address data transfer. We can unlock transfer speeds and latency that are not just as fast as Web 2, but potentially faster. Because we don't care where our data comes from. We can download from multiple parties at once because the addresses we use to get the data automatically verify that data. And we can't do that with traditional web addressing. We even have concrete evidence that this is true. There is an example of faster multi-party data transfer that is faster than Google.com or any of the super high bandwidth websites that are out there, and that's BitTorrent. Right? In BitTorrent, you download movies, obviously legally, from multiple home computers, not fast computers, right? But you get it super fast because you're downloading from many people at once. And even though individual nodes in BitTorrent are not that fast, or they're much more underpowered than a high-power server, you get an overall faster speed, right? So we're 20 minutes in, and you may have noticed I haven't mentioned either BitSwap or GraphSync. Well, I did mention BitSwap very briefly, but if you're familiar with data transfer on IPFS, you know that these are the two most commonly, oh, oops, sorry. Hope I'm not spending too much. Yeah, go ahead. Sorry. You know these are the two most commonly used data transfer protocols, and I haven't addressed them yet because I want you to think broadly, right? Content address data transfer is actually in its infancy. We're just learning about this stuff. And we shouldn't be locked into the solutions we have already. Even though they're pretty well developed, I think there are way better options out there eventually. Maybe the minimum standard to be content address data transfer is simply that you ask for the data by its SID, and ideally, you should run some code to verify the data against the SID you requested. So could HTTP be a content address protocol? Do you need libp2p to be a content address data transfer protocol? I would actually argue that it can. I know this is a bit controversial. If you hit up any website, and in that website, either in the path or the subdomain, is the SID, right? And then you transfer back a block or maybe even a car file, then you can run some code, and then you run some code to verify what you got back. You have now got content address data transfer. Now, if you ask for data from the IPFS gateway, is it content address data transfer? In its current state, not completely, because what you do is you ask for a SID, but then you trust the IPFS gateway to send you back the right stuff. And, you know, that means you're trusting, you know, I don't know, somebody, us, Protocol Labs, I'm not sure. I don't, you know, we could be stealing your stuff. Anyway, but we're almost there. If instead of downloading a file directly, you download a car file, you can actually verify it. You'd have to run some code on your own machine, but even the gateway could be a content address interface. So that's the minimum. But what about for the overachievers, right? Who wants to write the best data transfer protocol and get into, like, I don't know, the fancy programmer school? If you want to write the best content address data transfer system, what should it include? If you're making an implementation, what should you consider? So this is where the mess happens. Everything's going great, and you realize the oven is off, and in 10 minutes, Paul Hollywood is going to spit out your signature bake and give you a good talking tool. Writing good content address data transfer is actually quite hard. And these are the things that you're going to need to do it well. So first of all, good content address protocols shouldn't leave verification until the very end. Basically, what this means is, like, I shouldn't accept 10 gigs onto a home computer's hard drive before checking to see if it's the data that the user asks for. And this changes with context, right? If I'm transferring huge amounts of data between data centers, maybe that number could be much larger. But generally, we shouldn't be, like, just messing around with, you know, throwing unverified data all over storage, over hard drives and other user storage systems. The next thing you probably want to do is you want to think about how you make content address transfer requests. Implementations should think about how to get the data fast, right? This is what we care about. And it should figure out how to split a large request into smaller requests across multiple parties, ideally avoiding duplicate data and using maybe locally cached data. One more pitfall, this is really more of a pitfall than anything, is that that you can sort of break a data transfer protocol with, is that both sides have to understand the data you're transferring. And they have to understand it on the same level. This will become more clear once you know a little more about IPLD, which you'll get in the next talk. But basically, if you don't both understand the data you're transferring and in the exact same way, you may not be able to move that data, right? And this comes up a lot, especially if you're trying to work with data at higher and higher levels of abstraction, where you can't rely on the other peer to understand all of those levels, right? Finally, second to last, a good implementation of content address data transfer should protect the side that is sending the data. This looks very similar to the kinds of concerns you would encounter when writing HTTP servers. You need to keep data moving, you need to protect resources, and you probably should try to figure out how you're going to protect against DDoS attacks. And then lastly, you need a plan for when things go wrong. And man, things can go wrong. Connections can get dropped, remotes can be missing data that they said they have. You can end up with all kinds of race conditions and consistency issues if you're doing multi-party transfer, and you've got a plan for that. So here we are, and suddenly things aren't looking so easily. This is basically my expression over the last few years after I volunteered to write some transfer protocols for our stack. But I believe that you all are smarter than me, and you're going to figure it out. Again, this is an outsourcing talk. But to help you figure it out, I'm gonna ask all of you who just really want to talk about BitSwap, and that's why you came, and you're like, what the heck is all this meta philosophical crap? Just wait a little longer, it's coming, there will be lots of it. And I want you to help me solve these problems, so I want you to understand them.